Okay, we want to talk about the unit circle, a most powerful tool we will use to develop the building blocks we need for our journey with trigonometry. First, what is a unit circle? Well, it is a circle centered at the origin with radius equal to 1. We know the point 1, 0 lies on the unit circle, 0, 1 lies on the unit circle, negative 1, 0, and 0, negative 1. Those are 4 important points that lie in the unit circle. And given any point that lies on the unit circle, let's say x, y, it will satisfy the formula x squared plus y squared equals 1. That's what it means to lie on the unit circle. Now, what's true about all circles centered at the origin is that they have some symmetric properties. If I know the point xy lies on the unit circle, and this is true for any point xy, I know that the point negative xy also lies on the unit circle. I know also the point negative x negative y lies on the unit circle, and the point x negative y lies on the unit circle. So if I know any one point on the unit circle, I automatically know 3 other corresponding points. Okay, let's draw a triangle that passes through the point xy, a right triangle. So first of all, let me draw the hypotenuse of this triangle, and notice that this line segment forms a radius of my circle, so I know that it has distance 1 as well. Now if I drop down this vertical line and form the right triangle, I'm going to call this angle theta. And notice that theta corresponds to this particular point xy. If I were to move my point to somewhere else on the unit circle and draw its hypotenuse, I would get a new angle. So this theta corresponds to this point xy. This distance right here is x, and then this distance right here is y. Now recall in an earlier video we talked about the ratios of the lengths of the side relative to the angle theta. Let's recall a couple of those. We know that the sine of theta was equal to y over the hypotenuse, which in this case is 1, and that reduces to just y. The cosine of theta was equal to adjacent over hypotenuse, or x over 1, which reduces to just x. And this is pretty cool. This tells me that every point on the unit circle can be instead represented in terms of that angle theta. Cosine theta, sine theta. Okay? So for any point xy, we can rewrite it as cosine theta, sine theta, where theta is the angle formed as I make this right triangle passing through that point xy. Now let's see what that actually means with our 3 special triangles we talked about in an earlier video. So here's a unit circle again, and this time I drew some lines to represent the angles of my 3 special triangles. So let's let this outside one correspond to 60 degrees. This one right here, 45 degrees, and this one right here, 30 degrees. And I can form 3 triangles, 3 right triangles. So this will be a 30, 60, 90 triangle. If I drop this vertical line down, I form a 45, 45, 90 triangle. And then if I drop this one down, I'm going to form a 60, 30, 90 triangle. Okay? Now what we just discovered was that each point here can be written in terms of its corresponding angle. So I know this point should be cosine of 30, sine of 30. This point should be cosine of 45, sine of 45, and this point should be cosine of 60, sine of 60. Okay? So we have that from what we just discovered on the earlier page. Now, What we also remember from an earlier video is that we discovered what all of these values were when we were constructing our special triangles. We made a chart and we committed ourselves to knowing this chart. So remember what our charts told us. For these given angle thetas, we knew what the cosine of those angles were and the sine of those angles were. So what we can actually do now is replace each one of these expressions with their corresponding numerical value. And we're going to do that. So I'm going to move this one, get a new, cleaner unit circle. And then let's fill in those points. So recall, this point right here should be cosine of 30 sine 30. So looking at my chart, the square root of 3 over 2, the sine, square root of 3 over 2, 1/2. That's cosine of 30 sine of 30. This point right here should be cosine 45 sine 45, or 1 over the square root of 2, 1 over the square root of 2. And this point should be cosine 60 sine 60, or 1/2 square root of 3 over 2. And that's pretty neat, because we've now identified 3 points that lie on my unit circle that correspond to 3 special angles, 30, 45, and 60. Now remember, the relationship I told you was true about all points that lie on the unit circle. They satisfy that equation, and I dare you to take each one of those points and plug it in and see if I'm telling the truth. Okay, remember what we also discovered or talked about any circle, so that includes this one that's centered at the origin, were its symmetrical properties. And so we knew that if we knew any one point on the unit circle, we knew 3 other corresponding points. They were the same in value, they just differed by signs. So we know that this point corresponds to this one, and this one. And if we rewrite them, we know it's just different by my x sign, so it's negative 1/2 positive square root of 3 over 2. This point right here is negative 1/2 negative square root of 3 over 2. This one right here, make sure we get it all on our screen, is positive 1/2 negative square root of 3 over 2. Now this one moves around here, here, and here, so this point corresponds to negative 1 over the square root of 2, positive 1 over the square root of 2. This point right here, negative 1 over the square root of 2, negative 1 over the square root of 2. This one right here, positive 1 over the square root of 2, negative 1 over the square root of 2. And last, let's follow this point all the way around. So this point right here should be negative square root of 3 over 2, positive 1/2. This one should be negative square root of 3 over 2, negative 1/2. And this one should be positive square root of 3 over 2, negative 1/2. Now, your job still remaining is to figure out what each of these lines, or what angle each of these lines represent, so that we can interpret this unit circle even further. But that will be for another time.